All right, in the trigonometry, lesson 6-1 on inverse circular functions today. And we will be calculating the arc sine or arc, tangent, inverse tangent of functions. Before we can actually do that part, we need to discuss what would we need to do to the basic sine graph or the basic cosine graph. What kind of restrictions would it need to be such that its inverse would be a function? In other words, I'd have to look at the original graphs, and I've got a cosine graph here for you. So if I'm looking at this original cosine graph, right now I'll be, well, it is a function. All the x values are different. But see, it doesn't have an inverse because the inverse would not be a function. Remember, for it to have an inverse, it has to pass the horizontal and the vertical line test. It had to be 1-to-1. So since this was not 1-to-1, we would say it doesn't have an inverse. But if I was to restrict the domain such that it would be 1-to-1, then we could work with the inverse of the cosine. So if you take a look at the graph down below, I have restricted the domain from 0 to pi. The yellow graph actually is 1-to-1, and therefore it would have an inverse. So your inverse cosine, when you're calculating those values, all your answers will be between 0 and pi, or they'll be between 0 and 90 degrees. All right, let's take a look at the sine graph now. So the sine graph, remember, that started at the origin and going up and down. Now, my sine graph, that is also not a 1-to-1 function either. Okay, again, it would not pass the vertical and the horizontal line test. But what we are going to look at is if I was to restrict it. See, if I was to restrict it from the negative pi half to pi half, the yellow part of the graph actually would be 1-to-1. It would pass the vertical, it would pass the horizontal line test. So when we calculate the values for the inverse sine, all the answers will be between negative pi half and positive pi half. Or if it's in degrees, between negative 90 degrees and positive 90 degrees. Now for the tangent graph. So our tangent graph looks similar to this. Starts at the origin and has asymptotes, 0 asymptote, 0 asymptote. Again, it's not a 1-to-1 function if you use all the branches. But if I was looking for what would I need to restrict the domain to be such that it would be 1-to-1 without having any breaks over the asymptotes, my domain would then have to go from negative pi half to pi half. From negative pi half to pi half is where all your answers will be if it's for inverse tangent or arc tangent, or they'll be between negative 90 and positive 90 degrees. So with that in mind, one of the things you guys are going to want to add to your memorization list would be this. When we ask you for the inverse sine or inverse tangent, or arc, sine, arc, tangent, it will always be from these two quadrants here. And we just go from negative 90 degrees to positive 90 degrees. When I ask you for the inverse cosine or inverse cotangent, it will always be for the top two quadrants, and your answers will go from 0 to 180 degrees, or from 0 to pi radians. So this is asking you, when is the arc sine of square root of 3 over 2? So when we're looking for the arc sine of radical 3 over 2, I'm basically asking you the sine of what angle is square root of 3 over 2. So if you take a second and get you out some paper, you need to definitely write down your 30-60 triangle and your 45-45 triangle ratios. All right, now that you have done that, remember we were looking for, when is the sine of an angle square root of 3 over 2? See, the sine of an angle to be the square root of 3 over 2, that would be at 60 degrees, would be square root of 3 over 2. So that answer would be 60 degrees. Now, if it's in radians, then I would have to put my answer in radians, and therefore then it would be pi over 3. All right, the next one's asking me, when is the arc sine negative 1/2? Now, remember we were restricted earlier. We restricted the arc sine such that they would have an inverse that would exist. So arc sine and inverse sine are both restricted to the two quadrants on the right. So if I get an answer that's in quadrant 1, that would just be my answer. But if I get an answer that's in quadrant 2, in this case I would. Because see, the sign is negative down here. It is not negative in the top quadrant. So again, the inverse sine to be negative 1/2, I'm looking for when that is going to be down here into quadrant 4. Now, when is the sine 1/2? Take a look at your 30-60 triangle. So when is the sine 1/2? The sine of which angle? Well, that would be the sine of 30 degrees. the sine of 30 degrees is 1 over 2. So therefore my answer would be negative 30 degrees and negative pi over 6. And again, if the angle was up here, we would just leave it the positive, but if it goes down, then we just take negative of that angle. Because remember, we restricted this domain such that the angles went from negative 90 degrees to positive 90 degrees for our answers. This one's asking me, when is the sine square root of 2? So again, it would be positive, so that would put me in the top right quadrant, into quadrant 1. When is the sine square root of 2? If I took a look at this, I actually have the cosine or sine of 45 are both 1 over square root of 2, but not square root of 2 over 1. See, this is a square root of 2 over 1. Square root of 2 is bigger than 1. See, that would be asking me, when is the opposite leg square root of 2 and the hypotenuse to be 1? That can't happen. See, square root of 2 is larger than 1. So the inverse sine is not going to exist for the square root of 2. Again, it would have been in the quadrant 1 because it was positive, but the square root of 2 over positive 1, this would be square root of 2 over 1 for opposite leg over hypotenuse. That opposite leg cannot be bigger than the hypotenuse of 1. So therefore, this would not exist. All right, so when is the cosine 0? Sometimes you can't use the triangles for these. Sometimes you have to use the points that fall on the axis. Now, the inverse cosine is restricted to the top 2 quadrants. My answer should be between 0 and 180 degrees. So between 0 and 180 degrees, when is the x-coordinate 0? That's what that's asking. See, the cosine of what angle is 0? That's when your x over r is 0 over 1. So that x-coordinate would be 0 straight up right here at this point, 0, 1. And therefore, my answer would be 90 degrees or pi halves. On the next one, I'm asking, when is the inverse cosine 1/2? So again, the inverse cosine is restricted to the top 2 quadrants. That's the first thing you need to be concerned with. When is it positive? Well, that would be in quadrant 1. Then we're looking for the cosine of what angle is 1/2. So we take a look at our triangles. The cosine of what angle would be 1/2? And hopefully you're thinking that would be 60 degrees. So 60 degrees and pi thirds. Arc tangent. When is an angle's tangent of the angle the square root of 3? That's what that's asking. See, tangent's restricted to the 2 quadrants on the right. When is it positive? That would be in quadrant 1. Now, when is the tangent the square root of 3? Take a look at your 30-60 right triangle. Tangent meaning opposite over adjacent leg. So the opposite over adjacent would be square root of 3 at 60 degrees, which is equivalent to pi thirds. Now this next one, we want the inverse cosecant to be negative radical 2. Inverse cosecant is going to be your reciprocal of the sine. So we're basically asking here is, when is that sine value negative? So that would put me down into quadrant 4, but remember my answers would be a negative angle measure. We're not going to go all the way around to the 360. So therefore, I'm asking, when is the cosecant negative square root of 2? Now cosecant was the reciprocal of sine. So we're basically asking, when is the sine negative 1 over square root of 2? Well, the sine of what angle is 1 over square root of 2? That would be the sine of 45 degrees. So the reference angle is 45 degrees, but because we went down into quadrant 4, my answer would be negative 45 degrees or negative pi fourth. For these problems, you'll need your calculator. So go ahead and take a second, pause the video, grab your calculator. Okay, now that you've gotten your calculator, you'll need to go ahead. I prefer my mode to be in degrees at all times, even for problem A. Now, some of you might like rather go ahead and put your mode in radians for A and then change it to degrees for B. And that's just a personal preference. Okay, so like I said, I'm going to have my mode on my calculator in degrees. So the button mode is to the right of the word second. And when you go to mode and your arrow down, and you'll see where the word radian is and degree. And notice I have my degree is highlighted. So again, I just prefer to work with degrees and then convert my final answers to radians. But if you want to switch back and forth between radians and degrees for the problems, please feel free to do so. Now, one of the issues with this one for the calculator is that we don't have an inverse secant button. We have an inverse sine, inverse cosine, or tangent, but not the inverse secant. So we do need to rewrite this first. So what we would do is take this secant of both sides. So therefore that would end up, and this secant here is the reciprocal of the cosine. So we know my final answer is going to have to be in quadrant 2 because this was the negative value. So again, inverse secant and inverse cosine are restricted to the top 2 quadrants. So since that value was negative, I do know I need my answer into quadrant 2. Now, if I take the secant of some angle to equal -4, we know secant is the reciprocal of cosine. So therefore, I'm going to take the cosine of some angle would be -1/4. Now, when you want to get your reference angle, what you will end up doing is taking the inverse cosine of +1/4. Whenever you want the reference angle, again, you'll just take inverse, whichever the trig function is, but then only of the positive values. So I would type in then as the inverse cosine of 1/4, and that will give me my reference angle. And in this situation, so this is what it'll look like, inverse cosine of 1/4. Now my angle measures 75.5224 degrees. But I want the angle over here into quadrant 2. So then I'm going to have to take 180 minus that reference angle. So now I know that my angle is at 104.4775 degrees. Then we want to convert this to radians. That's the only thing you guys have to be careful on this test is where people do end up getting answers wrong is they'll have it in the wrong mode. About half of it's radians and half of it's degrees. So again, like I said, you're either flipping back and forth or just always work in degrees and then convert to radians. So since this answer is in degrees and I need to convert it to radians, at that point then I would need to take it to times by pi and divide by 180. And therefore my final answer is that. So I divided by 180 and I times by pi, and I should end up with 1.823 radians. All right, the next one was find theta in degrees for the arc cotangent. So I'm going to take the cotangent of both sides. And also arc cotangent is restricted to the top 2 quadrants. The value is negative. Again, I will be in quadrant 2. All right, now we take the cotangent of both sides to get rid of the word arc cotangent. So therefore the cotangent of theta equals negative 0.2528. Cotangent is the reciprocal of tangent, so therefore that would be the tangent of theta equals -1/0.2528. Again, to get the reference angle, you ignore that negative sign, and you would just type in then, at that point, is the inverse tangent of 1 divided by 0.2528. So this is what I want into my calculator. The inverse tangent, and that's by pushing second tangent, of 1 divided by 0.2528. So my reference angle is 75.81 degrees. Now that's the reference angle, which is this little measurement here. But to get the answer for my angle, I've got to get all the way to that green vector. So therefore I would have to take 180 minus the answer I just received on my calculator, the 180 minus this 75 degrees, to give me this final answer of 104.187 degrees. Let's pause it. All right, so this one's asking me to evaluate the cosine of the inverse sine of 2/3. Whenever you see the inverse, you just need to think about that means of some angle. So what this problem is asking me is find the cosine of some angle such that at that angle, the sine of it is 2/3. So again, this is asking me to find the cosine of an angle such that the sine of the angle is 2/3. So it really helps on these to kind of think about, first off, what quadrant does it fall in? So the inverse sine to be positive 2/3. The inverse sine to be positive is going to be in quadrant 1. In quadrant 1, my x and y's would both be positive, and that r would be positive as well. The sine is the y over r, so that is the 2/3. My Pythagorean theorem, I would need to take 9 minus 4, so my x would be the square root of 5. Now I want the cosine of that angle. The cosine of an angle is the x over r, so my answer would be the square root of 5/3. Okay, and this one's asking you for the secant. Find the secant of some angle such that the cotangent of that angle is -15/8. So the first thing that we want to look for is the cotangent is negative where? See, the inverse cotangent is going to be restricted to the top 2 quadrants, and since it's negative, that would put me in quadrant 2. In quadrant 2, do remember that the x value would be negative, the y would be positive, and the r is always positive. Cotangent would be the x over r, so therefore that would be the 15 for x and the 8 for the y. Pythagorean theorem, we would end up with 17 for r. You'd have 15 squared plus 8 squared, and then take the square root. We're looking for the secant at that angle. The secant happens to be the reciprocal of the cosine. The cosine would have been x over r, so therefore we need r over x. My answer would be negative 17/15. This time I want to find the sine of some angle minus another angle. These are two different angles. Now for this angle, the tangent of it happens to be 4/3. The cosine of the second angle happens to be 12/13. So again, I'm looking for the sine of an angle minus some other angle. And I know it's kind of a little bit weird. So what I'm going to do is call this one right here angle A, and I'm going to let this one be angle B. Now, realizing then that means that angle A is going to be the inverse tangent of 4/3, and my angle B would be the inverse cosine of 12/13. Now, both of these are positive, so that's going to go ahead and keep me in quadrant 1. Here's my picture for angle A. The tangent would have been the y over x, so that would be the 4 for y and 3 for x. Pythagorean theorem, that r would be 5. My picture for angle B, again, the cosine of the angle would be 12/13, so that would be my x over r. So there's my x and r. I need to take 13 squared, take away 12 squared, so 169 minus 144. That's 25. The square root of it would give me the y is 5. So what we're actually doing for this problem, I need to figure out is what is the sine of angle A minus angle B? Well, if you go back to those pink sheets for our formulas that I had ran for you, and remember you'll be given the formula on your final exam as well. So we're looking for the sine of A minus B. So the sine of A minus B was going to be the sine of A, cosine of B, minus the cosine of A times the sine of B. So we fill that in. The sine of A, you go to angle A, you choose your y over r. You go to angle B for cosine, choose x over r. Go back to angle A, the cosine would be x over r. And the sine, go to angle B and choose the y over r. And these are the values you get. This denominator is 65, and so is this denominator. The numerator is 48 minus the 15, and both of them are over 65. Evaluate this one. We want to find the sine of 2 times the arc cotangent of negative 5. So again, this one's asking me for the sine of 2 times some angle. I need to figure out what the sine of 2 times some angle. Now remember that angle exists such that the cotangent of it is negative 5 over 1. Now, cotangent is restricted to the top 2 quadrants, and since the value is negative, that puts me in quadrant 2. Cotangent is the x over y, so therefore the negative 5 over 1, so the x over the y, negative 5 over 1. Pythagorean theorem, you're going to have square root of 26 for the r. Now we want the sine of 2 times that angle. The sine of 2 times the angle, if you go back to the pink sheet again, so the sine of 2 times some angle is 2 times the sine of the angle times the cosine of it. So that's what we're going to do. Now, the sine of the angle would be the y over r, which was 1 over radical 26. The cosine of it's negative 5 over radical 26. These two multiply, gives me a pair of 26s, so the denominator would be 26, when the numerator would be 2 times 1 times negative 5. So the numerator was negative 10, the denominator 26, that reduces to negative 5/13. Then we moved on and we did these with a u instead of a number. So I wanted to know the cotangent of the inverse secant of u. And they are giving me that the u is positive, so that's going to put me in quadrant 1. So we are in quadrant 1. We want to know when the secant is u. So the secant of u. The secant of what angle is u over 1? So that would be the reciprocal, which would be the cosine of some angle is 1 over u. The cosine is your x over r, so therefore 1 over u. If you do Pythagorean theorem, you're going to have u squared minus 1 squared, and then take the square root of that for the y. Now we're asked to find the cotangent of this angle that we just drew a picture of. So I want the cotangent of that angle, and the cotangent would be the x value over the y value. Can't leave the square root in the denominator, so we would multiply top and bottom by the square root of u squared minus 1. So the numerator just stays the square root of that. The denominator is now just a u squared minus 1. This was asking me to find sine of 2 times of some angle, such that that angle, the cosine of it, is u over 1. Again, since the u is positive, that would put me in quadrant 1. So again, the cosine of the angle is u over 1. So that would mean that's my x over r is u over 1. Pythagorean theorem, I'm going to have 1 minus the u squared and the square root of it. Now I want the sine of 2 times that angle, And on that pink sheet on your formulas, the sine of 2 times an angle is going to be 2 times the sine of theta cosine theta. The sine of theta is the y over r. The cosine of theta is the x over r. The y over r, meaning the square root of all this stuff over 1. The x over r was the u over 1, and that's what you would get for your final answer. For this problem here, you do not need to memorize the formula. This one was mainly to discuss with you guys the best way to type this into the calculator. When you guys are typing this one in, the best thing for you to do is going to be just to type in, this is somebody throwing the shot put, what would be the optimal angle for him to throw this ball at. So his height here is a 7.5 foot. 7.5 feet is where he's releasing the ball. And the initial velocity is going to be 50 feet per second. At what angle should he throw the ball to maximize his distance? So we plug it into this formula. We're going to take that velocity and we square it, divided by 2 times the velocity squared plus the height, the 64 times the height. The best advice I can give you is to type in just what's on the inside. But when you do type in on what's on the inside, please make sure you do the entire denominator in parentheses. If you don't, you will end up getting this answer incorrect. So let me kind of show you. So here's what I've done so far. I typed in the 50 for the numerator and then divided by, and notice I have the entire denominator in parentheses. Now what I want is the arc sine of the square root of that answer. So then I just type the second sines, that's going to give me my inverse sine, of the square root of that answer. And this will keep you from making some careless mistakes. So again, because everybody gets confused on all the extra parentheses. So again, what I prefer you to do is to type in your numerator. Sorry, I make it not be blurry. All right, so there's the numerator of 50 divided by the entire denominator in parentheses. Then I wanted the inverse sine of the square root of the answer, and that's how we ended up with this final answer here. So he needs to throw it at an angle. Oh, and my mode was in, something's not right. My numerator is supposed to be 50 squared, so that's why the calculator is not correct. Let me redo that. So 50 squared divided by 2 times 50 squared plus 64 times 7.5. All right, now I want to do the arc sine of the square root of that answer. Now we have our 42-degree angle. Okay, so that numerator was supposed to be from the formula right here. I was supposed to have had a velocity squared. Sorry about that. So there's my velocity squared, and then the entire denominator, and then I wanted the inverse sine of the square root of that answer. So 42.48 or 47 degrees he needs to throw the ball at. That's the end of 6-1.